Good morning, everybody. Today's topic is Heisenberg Uncertainty Principle. In this module, you will learn about Heisenberg Uncertainty Principle. So, if we know the position and momentum or velocity of a moving object of different points of time, then we can predict its path from one place to another. It is impossible to know the velocity of an object simultaneously and accurately. Regarding this, an important principle given by Werner Heisenberg, a German physicist in 1927. The principle called Heisenberg uncertainty principle, it states that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an object. Mathematically, delta x into delta px is more equal to h upon 4 pi, where delta x uncertainty in the position of an object, delta p uncertainty in its momentum of an position x, and h is Planck constant. Where delta px equals to m into delta vx. So in equation, it can be replaced m into delta vx. So you can see the equation could be like this. Delta x into delta vx is more equals to h upon 4 pi m. Where delta vx uncertainty in the velocity of an object at position x. Heisenberg uncertainty principle in case of macroscopic object. Since macroscopic object is large in mass, the uncertainty in position and velocity of macroscopic object is of no significance. Thus, this principle is insignificant in case of macroscopic object. Whereas, in case of microscopic object like electron, the mass of electron is negligible. So, delta x into delta v is significance means delta x will decrease, then delta vx will be increase. This fact can be explained experimentally. To locate a position of electron, we need to illuminate with some radiation. The radiation used have a wavelength smaller than the dimension of an electron. It means wavelength must be extremely small. When high momentum of photon of such radiation strike with an electron, the energy of electron considerably change. This means momentum of a photon P equals to h upon v, where where wavelength will be very small. And there is a sudden considerable change in velocity of the electron. Thus, uncertainty in velocity increase considerably when we try to locate the exact position of an electron. In case of microscopic object, delta x into delta vx is more equals to h upon 4 pi m. The uncertainty principle in highly significance for microscopic object, as it is impossible to know the exact position and velocity of an electron simultaneously. It is also It is also not possible to predict the path of an electron. The uncertainty principle rule out the existence of fixed trajectories of electron as suggested in the Bohr's model of an atom. Heisenberg's uncertainty principle highlight the shortcoming of Bohr's model and become an important step towards the quantum mechanical model of an atom. So in this module, you will have learned Heisenberg uncertainty principle state that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an object. Mathematically, the uncertainty principle is given as delta x into delta v is more than equals to h upon 4 pi m. And Heisenberg uncertainty principle is not significant for macroscopic object, but it is considerably significant for microscopic object. So Heisenberg uncertainty principle rule out the existence of fixed trajectories of electron as suggested in the Bohr's model of an atom. Thank you. Have a nice day.